Hello everyone, Mr. Sutherland here, and we're going to continue working on section 9.1 today. We're going to do a little more with solving the quadratics by graphing. So if you remember last time, we had these quadratic equations that we solved by looking for their x-intercepts, and we're going to continue with that today, kind of adding something, looking also for the vertex. And then we're going to look at what happens when we're trying to solve one of these equations and it's not in standard form like you see here. And so that's going to be our focus today. But the first type of problem we want to do is, and we'll just start with an example here. Example 1, what I want you to do is find the roots and the vertex of the function. So we'll say of the following. So let's say the first one is y equals negative x squared plus 8x plus 84. So a thing with vocabulary here. When I ask for the roots, what that means that we've been doing is that's the same thing as asking what is the zeros? What are the zeros of the functions? Or what are the x-intercepts? It's just another word that means the same thing that we've been doing. So we have our function here. So we want to graph it and see if we can find the roots and the vertex of the following. So I'm going to go to my graph page and my calculator. And we're going to graph. And I've got negative x squared plus 8x plus 84. Now, what you're going to notice here is we don't see much of the graph. We know we should have a parabola, right? We should have something that comes up and goes back down, or something that goes down and comes back up. One of those two things. So I'm going to change the window here on the graph so that we can see more. So the first thing I'm going to try is I'm going to go to Menu, to Window, and I am going to do all the way down at A, which is called Zoom Fit. Now look at what that did. I can see the vertex up here. I can see one of the places it crosses the x-axis here. We can't see the other one. So the other thing we need to change here, it looks like, is my x maximum. So I'm going to go to Window again. I'm going to go to my Windows settings. And now the only thing I need to change is my x maximum. So I'm going to make it, instead of 10, let's make it 30. And now I can see everything. So now we can do what we did last time. Let's find the roots. Remember what the roots, the same thing as finding the 0. So I've got 1 at negative 6. And then if I do the 0 again, I have 1 at 14. Now, the next thing I need to do is find the coordinates of the vertex. So the vertex is up here. And we can see in this case, the parabola opens down. So this is a maximum. So I'm going to go Menu, Analyze Graph, Maximum. I'm going to go to the left of the maximum. I'm going to go to the right. And there is our graph. So we have, let me sketch this out here. Again, we just have to do a basic sketch. And we had a parabola that opened down. And now we had one root, one x-intercept at negative 6, the other one at 14, and we had the vertex at 4, 100. So if the question asks, what are the roots? I can say the roots are negative 6 and 14. You don't have to write the coordinate ordered pair when they ask for the roots. And our vertex of this graph is 4, 100. So just a little bit different from yesterday. You have to expand the window a little bit, and we're also going to work on practicing finding the vertex because we're going to do that a lot in some applications coming up. So why don't you try this problem next. So pause, graph it, see if you can change the window on your calculator in order to see everything so that you can tell me, just like we did in the first problem, what are the roots of this problem, and then what is the vertex. And we'll just have our graph over here. Okay, I think hopefully you've tried it now. And now let's take a look at this problem. So I'm going to do Control I. I'm going to put in a new page. I'm going to do a second graph here. And for this graph, we had x squared minus 6x minus 81. Press enter. Again, I just see one of the zeros, one of the x-intercepts, one of the roots. So I'm going to go to my window. So that's here. And I'm going to go all the way down first to A, which is zoom fit. That allows me to see this minimum. Move this out of the way. Now we can see here's one x-intercept. The other x-intercept should be right over here. So the other thing I have to change when I go back to window, I need to go to settings, and then I'm going to change this to the, oh, something happened here. Let me escape out of that. Let's try that again. So I'm going to do window, settings. I'm going to change this 10 to a 20. And I can see everything. So now we can do the analyze graph, find the zeros. Oh, this is good. We have one that's not necessarily a whole number this time. Menu, analyze graph, find the zero over here. And then this time when I go to find the vertex, if I look at my options, this one is a minimum. It's the lowest point. It's not a maximum this time. So I move over and I've got my vertex. So it, as far as how many decimals to show, it depends on what the assignment asks. It asks for the nearest tenths, you would do 1. Nearest hundredths is 2. So let's do hundredths. So that means this would be negative 6.49. So I'm going to go back to my work here. Let me peek at the graph again. So we had a parabola that opened up like this. We got negative 6.49 comma 0 for that intercept. On the right hand side we have 12.49, and then our vertex was at 3, negative 90. So for the roots, I could write negative 6.49 and 12.49, and our vertex is 3, negative 90. Again, next time we do some new material, we're going to do some applications where we need to be able to find the vertex on our calculator. So that's why we spent some time doing that. And the otherwise is to review the finding the zeros like we did last time, except this time, again, these words are all the same, everyone. We could use the word roots, we could use the word zeros, or we could use x-intercepts. They all mean the same thing. All right, second topic I want to discuss today would be doing this same type of problem. So I'm not going to change the directions. I'm going to call this example 2 though. But I'm going to say this time, let's just solve each quadratic equation. So we're not going to worry about finding the vertex. We're just going to solve the equation. So this is what you did yesterday, right? We solved these equations by graphing, but here's the twist I'm going to put on it. Here's the first equation I want you to solve. X squared minus 3x equals 5. Now, I'm going to flip back to yesterday's notes. Now, if we look at yesterday's notes, notice what I highlighted on each of these. In order to solve by graphing, we got the quadratic equation so that it was equal to 0. In this case, it's not equal to 0. So before we graph this to find the zeros. To solve this equation, we need to get everything on the same side. So in this case, I'm going to subtract 5 from both sides of my equation. Now, when I do that, I get x squared minus 3x minus 5, right? I can't combine those. Those aren't like terms, equals 0. Now that we have this is equal to 0, now we can do what we just did. We can sketch this graph. So I'm going to do a new graph. So we have x squared minus 3x minus 5. I can see both zeros, so I'm going to go ahead and analyze graph and find both of those zeros. So it looks like negative 1.19 and 4.19. So I'm just going to jot that down here in my work. So we have negative 1.19 and 4.19. And what that does is that tells us the solutions to this equation. That tells us when these are equal to 0, because when it's equal to 0, that's our x-axis. So clean this up here, 4.19 comma 0. So my solutions are x equals negative 1.19 or x equals 4.19. Okay, let's look at a second one like this. So B. So for this one, let's do 2x squared plus 3x equals x squared minus 9. So what I'd like you to do is move everything to the same side, so this equals 0, graph it, and see what the solutions to this equation are. Okay, hopefully everybody gave this a shot to try it. I'm going to do this in 2 steps. You might have done this in 1 step. First thing I'm going to do is I'm going to subtract x squared from both sides. They are like terms, so I line them up. 2x squared minus 1x squared is just 1x squared, plus 3x equals negative 9. Now I'm going to move this 9 over by adding 9 to both sides. So I have x squared plus 3x plus 9 equals 0. So now I'm going to make my grid, and we are going to solve this equation. So I'm going to go to my graph, and we had x squared plus 3x plus 9, and graph that. Don't see anything. Let's do a zoom fit and see if we can figure out what's going on. Not that. So menu, window, down to zoom fit. Oh, there's our graph. Now what do you notice here, everyone? Well, our graph, oops, sorry, I didn't mean to grab it there. Let me just stop there. Our graph is a parabola that opens up, but it's always above the x-axis. So if we think of graphing this, we have a parabola that looks like this. And so again, when we're trying to find when it equals 0, we're looking where it crosses the x-axis. This one does not. So this one has no solution, is what we would write. It never crosses the x-axis. So let's review what I want you to be able to get out of today's video. First, being able to find the zeros and the vertex of a graph using technology. Again, you could do exactly what I did on the calculator by using Desmos if you want to. You can still find the zeros, you can still find the vertex, you can move around the screen a little bit in order to see those things. And then the second thing was, let's go back to solving quadratic equations like we did in 9.1a, but they don't always start as they're equal to 0. And what do you have to do to make that work? So based on this, try the homework for the next day and let me know if you have any questions. Take care, everyone. Bye.